Hello everyone, so this will be the tutorial for your LabVIEW VI setup that will be used in the wind tunnel experiment starting fall 22 in the Energy Systems Lab. So this should be the final product of your VI after you have followed each step. I will go ahead and show you guys step by step on what you're going to be doing. Once you've opened up LabVIEW and selected create a new VI, you're going to then create the DAC assistant that we need. So you're going to right click, go to measurement input output, NI DAC, and in there you're going to be able to find the DAC assist that we're going to be using for this lab. So you're going to go ahead and click the DAC assist and drop it into your block diagram interface. Once you do that, it will just ask you for some configurations. We know that this is a signal acquiring lab, so you'll be acquiring 8 signals from 8 pressure transducers. So what we're going to do is we're going to click acquire signal. We know that this is an analog signal coming from our pressure transducer via pressure. And we're going to click analog input, and we know that this is a voltage signal, so we're going to make sure that we choose a voltage. If it was a different type of signal, like a strain signal, we would choose that, but in this case we're choosing voltage. We're going to be prompted to choose a number of inputs. This will be, so in this first example, we're going to choose the first input, and then we're going to choose finish. Once we hit finish, it'll start creating the signal inside of our DAC assistant, all the information that's needed. We're going to make sure the acquisition mode is in continuous samples, that our rate is 1000, our samples to read is 100, and our terminal configuration is in differential. Keep in mind that these pressure transducers are using a signal input range of -10 to 10. Once you hit finish, LabVIEW will start building the VI, and it will prompt you to create a loop that will verify that your DAC assistant is correctly calibrated and correctly configured. So next you're going to create a control for your number of samples and a control for your rate. This will allow you to have control over it when you are actually running each test. So you'll actually be able to access how many samples you're using without having to open up the DAC assistant block. So this is your setup so far. Nothing too crazy yet. The next thing that we want to do is determine how we can see the information that's being produced in our DAC assistant. So we're going to create a graph indicator. So you're going to right click the output of the DAC assistant, go to create, and click graph indicator. It'll pop up on your front panel on the right hand side. Once that happens, you're going to go ahead and double click your DAC assistant, and as you can see, all 8 voltage inputs are added, and we can see that the timing settings are also configured properly. We're going to hit connection diagram, and this will give you a schematic of the DAC that is connected to the computer and pressure transducer, so you actually see that there is a functioning loop and that the configuration worked. Once we're done with that, as you can see, channels in task show all 8 pressure transducers, all 8 voltage outputs that are going to be representing our pressure transducers. You're going to go ahead and hit OK. DAC assistant's going to get built. LabVIEW's pretty good with telling you if you messed up. All wires are connected, so we're good to go. So next thing we're going to do is create a split block. What this is going to do is help us order the signals that are being acquired from our DAC. Coming from our DAC assist, we're going to then connect the output of that DAC assist to that split block. So we're going to go ahead and go to Express in our Functions palette in LabVIEW, hit Signal Manipulation, and then find the split block up top. Once you acquire that, go ahead and drop that in the block diagram section. I'll show you how to expand that in a second. We're going to expand that input to output ratio from 1 to 8. So the DAC assistant is going to organize all of these signals that we have that are coming into our DAC. It's going to take all 8 of those signals and organize them through this split. So we're going to take that output from our DAC assistant, and we're going to connect that output to the input of our split block. And as you can see, there's nothing on the right hand side of that of our split block. That's where we're going to be connecting our average signal blocks to. So these are going to be blocks that are going to acquire an average signal from each pressure transducer being connected. So we're going to go ahead and go to mathematics, probability and statistics, and mean. You're going to drop that mean block, and as you can see, this also has an input and output function. So you're going to go ahead and click the output of our split module to the input of our average signal block that we just added. You're going to do this a total of 8 times, since again there are 8 pressure taps on the airfoil, and you're going to be able to acquire an average signal at different angles of attacks. Once you add those blocks, one really useful function is to select all, and then go ahead and go to File and Clean Up Selection. It's going to go ahead and organize all the blocks that you've added so you can continue to add on without any clutter. Next thing we're going to do is create indicators for each average signal. So as you can see, the DAC Assistant has a graph indicator so we can see what the output is, and it has controllers. Let's add some indicators for average signal so we can see them in our front panel. Go ahead and right click, go to create, and hit indicator. As you can see, the indicator will pop up on the right hand side every time that you add. Every time you add a control, it should pop up on the right hand side. You can do this again a total of 8 times since there are 8 average signals and 8 pressure transducers. Go ahead and clean that up one more time. Next thing we want to do is save this information. So how can we merge all of these signals into one file? So the easiest way that we're going to do this is using a function in LabVIEW called merge. So we're going to go to express, signal manipulation like before, and we're going to click the merge signal block. And again, we're going to do it 8-to-1 ratio, since those are going to be 8 output signals coming from our average signal blocks and being organized into a file so we have access to it after the lab. The next thing that we're going to do is connect the output wire of the average signal block to the input side of the merge block. So we're going to go ahead and do that for all 8 pressure transducers since we want to store all 8 values to a file. Now that all of our average signal blocks are connected, let's save it. So right click, we're going to go to express, output, since this is an output function, and we're going to find the right to measurements block on the left bottom side. Go ahead and grab that and drop that into the block diagram area. Once you drop it, you want to select the location in which you want to save that file. You want to make sure that use next available file name is selected so you're not overriding each trial that's being ran in LabVIEW. And then you want 1 column per channel since we have a total of 8 channels connected to our DAC. I'm going to go ahead and hit OK, expand just like we did the DAC Assist. Let's make some space so that we can connect the output of our merging signal block to the input of our signals. So these signals will be stored in a file that you chose. We're going to go ahead and create a controller which will allow us to enable when we do and when we do not want to save a trial. So if you want to save a trial, you can turn it on. If you don't, you can go ahead and turn it off. Next thing you want to do is go to the front panel and hit run continuously, and as you can see, all values are extremely close to 0 if not 0, and we have a system that's ready for pressure values. So you're good to go. Good luck on your lab experiment, and I hope you guys enjoy it.